Let's go to part 3. Let f of x equals 4x minus 9 over ax minus 3. Pass it through the point 2, -1. This will be x, here's y. We plug into this function. F of x equals y. So we have -1 equals 4 times 2 minus 9. A times 2 minus 3. Organize. -1 equals 8 minus 9 is -1. 2a minus 3. Then cross multiply. You will get -1 times 2a minus 3 equals 1 times -1 is -1. Distributive property, -2a plus 3 equals -1. Cross the river, change the sign. -2a equals -1 minus 3 will be -4. Divided by -2, both sides. A equals 2. So we have the function f of x equals 4x minus 9, 2x minus 3. For B, find the domain and the range of f of x. Domain, we need to make a denominator 2x minus 3 not equal to 0. Then x not equal to 3 over 2. For the range, y is not equal to, just check the coefficient of x. That is 4 over 2. That y is not equal to 2. For C, vertical and a horizontal asymptote line. From this domain, you will get the vertical asymptote line, x equals 3 over 2. From this range, you will get the horizontal asymptote line, y equals 2. For D, sketch the graph. When you sketch the graph, you need to figure out the x-intercept and the y-intercept. So for D, y-intercept, that will be f of 0. So 4 times 0 minus 9. 2 times 0 minus 5. 2 times 0 minus 3. You will get -9 over -3 equals 3. Y-intercept will be 0, 3. For x-intercept, you will set up f of x equals 0, which means 4x minus 9 over 2x minus 3 equals 0. Remember when we have a over b equals 0, which means a equals 0. So for rational function, we will make a numerator equals 0 to figure out this x-intercept. 4x minus 9 equals 0. Cross the river, change the sign. You will figure out x equals 9 over 4. So for x-intercept, 9 over 4, 0. First of all, you need to draw horizontal and a vertical asymptote line when you sketch any rational function. 3 over 2, that's 1.5. It's here. So x equals 3 over 2. For y equals 2, this is y equals 2. For the rational function with the linear over linear, there are two kind of graph. Either the graph like this or the graph like this. You have two types of graph for rational function with the linear over linear. That's the reason you have to locate y-intercept and x-intercept. Y-intercept is 0, 3. 0, 3 is here. And x-intercept is 9 over 4. It's a 2 point something. So that's over here. You just need to sketch your graph like this pattern. So basically like the first one. Let's go to number 2. Let f of x equals bx plus 7 over x minus 2. Passes through the point 3, 1. Find the b. This is x, here's y. So we plug into function. F of x is y. So we have 1 equals b times 3 plus 7. 3 minus 2. 1 equals, this is over 1, so 3b plus 7. Cross the river, change the sign. 1 minus 7 is negative 6 equals 3b. Divided by 3, both sides, b equals negative 2. So b equals negative 2. Find the domain and the range of f of x. We already got the f of x equals negative 2x plus 7 over x minus 2. For the domain, we will set up denominator x minus 2 not equal to 0. Cross the river, change the sign, x not equal to 2. For the range, we will set up y is not equal to. Remember the coefficient of x. This is 1. So negative 2 over 1. Y is not equal to negative 2. Look at the C. Find the vertical and horizontal asymptote line. Vertical asymptote line we will get from this domain. X equals 2. Horizontal asymptote line we will get from this range. Y equals negative 2. Then for the D, find x and the y-intercept. Let's do y-intercept first. F of 0 equals negative 2 times 0 plus 7 over 0 minus 2. So you have 7 over negative 2 equals negative 7 over 2. So for y-intercept, you will get the 0, negative 7 over 2. For the x-intercept, we will set up a numerator equals 0, negative 2x plus 7 equals 0. Then you solve. 7 equals 2x divided by 2. X equals 7 over 2. Then we sketch the graph. We have two types of graph for this rational function with linear over linear. Either or. First step, let's sketch a vertical and horizontal asymptote line. X equals 2. It's here. Y equals negative 2 is here. Then find the y-intercept. 0, negative 3.5 is here. For x-intercept, That's a 7/2, 3.5. It's here. Then you can sketch the graph now. So the graph like this, very close to this horizontal and vertical asymptote line, but never touch.